Lesson 5.3, Medians and Altitudes. Starting out this lesson, it actually gives you something another student has written that is incorrect, and you have to figure out why. So it says, Aisha wrote the following explanation of the relationships in a triangle. And it says, I can see that, and then she explains that all these angles are congruent because, and she tells you which segments. So you can look at the angles and the segments. And they bisect the sides opposite each vertex. By the concurrency of angle bisectors theorem, and then she says each of these will be concurrent, which means they intersect at one spot. But there's something wrong about this. So you might want to look at your notes from lesson 5.2. Something is incorrect. It says, why is Aisha's explanation not correct? And then down here, what can you do in the future to avoid Aisha's mistake? So try to find that mistake, try to see what's wrong. And if you can't find it, let your teacher know, talk about it, and figure out what is wrong with this because it's a common mistake. All right, example 1, identifying special segments in triangles. These are more of the vocab, and honestly, with lesson 5.2 and this lesson 5.3, this vocab is so easy to forget and it's so easy to mess up. So please take really good notes. Altitude and median. These are things you have to know. So it says an altitude is a perpendicular segment. So perpendicular 90 degrees from the vertex of a triangle to the line containing the opposite vertex. So it actually can be outside the triangle. And I'm going to color code this. This is the actual triangle. The altitude is from a vertex and down at a 90-degree angles containing the opposite side. Notice it doesn't have to be part of the opposite side. It is a line containing it. So it could be past this actual side of the triangle. So this is 90-degree angle perpendicular from a vertex to the line containing the opposite side. Whereas the median of a triangle is a segment that has endpoints at the vertex of one side and is the midpoint of the other side. And I don't know if you can see this, but these are tick marks. So this point B is the midpoint, and then it goes across to the vertex across from it. So altitude goes from the vertex to a side across from it at a 90 degree, whereas the median goes from the vertex to the midpoint. Midpoint is the median. All right, try it. Use the figure shown. What are the altitude and median of this visual? So look at the visual and you are going to name the segments. So hopefully you can find just by looking at this, where is the median? Name that segment using the letters A, C, D, B, E. And where is the altitude? Now you're going to identify them. So draw the other altitude and medians of the triangle. So if you look at this triangle, it's kind of hard to tell, but point D is supposed to be the midpoint. So I'm going to put little tick marks right here and here. So if that's the midpoint, this line right here would be the median. And then this point E, this is at a 90-degree angle and across to the vertex. So this segment is the altitude. Another way people call altitude is the height. So this is the altitude. What they're asking you to do is to draw all three altitudes and all three medians. All right, when you do this, find the midpoint using the two endpoints, make a circle and the same circle from both sides. Sometimes this program gives you a hard time because there are other segments involved, but do your best. It might be easier to do this on paper and pencil because an actual compass can find the perpendicular bisector. And basically all you don't need the perpendicular bisector, you just need the midpoint. So somewhere over here, that looks like about the middle, so that this side would be the same as that side. So you need that midpoint and go across to the other vertex. And I'm hoping what you'll notice is when you do this and you find the midpoint of this side, maybe it's right on there, midpoint, and you go to the vertex, they will be concurrent. So all of them will come together at one point. That's for the medians. Then you're going to do the exact same thing for the altitudes. And again, it might be easier on a piece of paper because sometimes the program is a little bit harder to use. concurrency of medians. Remember, concurrency is that 3 or more lines come together at one single point. So the medians of a triangle are concurrent at a point. So if I had all 3 medians, they would come together at one point. Notice midpoint, 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 and they reach across to the vertex. So that one point right there, that point of concurrency, creates a mathematical situation where the shorter side is 1/3 of the total length, and the longer side is 2/3 of that total length. So if you ever told that this is a median and you have the point of concurrency, if this was x down here, this would be considered 2x, and the whole thing would be 3x. That's a 2/3. So 1/3, 2/3, and then together it's all 3/3, or 1/2. All right, this problem says, what is the length of JN, this total? Now remember, this short side, or this long side right here, is 2/3 the total. So if I wrote this out, JN, that total, if I take 2/3 of that total, so 2/3 of JN will be 18. Because this distance, JQ, should be 2/3 of the total. So 2/3 of JN should be 18. Well, let's solve this. Let's solve for JN. So I'm going to multiply by the reciprocal, 3/2 on both sides. That's a 3 up there. So these will cancel out. So you'll have JN equals, and you can do this in a couple different ways. It might be easier to make this a fraction, and then see if there's anything on the top, the numerators, that simplifies with anything on the denominators, and it does. So I'm going to make this 2, and the 18 can reduce, so this would be a 9, and that would just be a 1. So 9 times 3, top times top, goes on the top, so that'd be 27, and then bottom times bottom goes on the bottom, which 1 times 1 is just 1. So I'd have 27 over 1, which I don't need, which means this whole thing is 27. So you're going to set up the equation. 2/3 of the total should equal 18. All right, this next part, same idea. It gives you the long side. So 21 will be 2/3 of this entire AD. So it says find AD. So set it up the same idea, the same way. So 2/3 of AD should equal 21. And do this the exact same way we did the last problem. And after you do your problem, fill it in, check your answer to make sure it's right. Find AD for this triangle. AD, notice this is the shorter side. So is this 2/3? This length, AE, is 2/3. This is 1/3. So 1/3 of the total of AD equals that 12. So you got to be really careful, and that's a common error. Notice if it's the short length or the long length from that intersection of medians, that point of concurrency. And if it's the short side, it's 1/3 of the total. If it's the long side, it would be 2/3. Okay, we're going to locate the centroid. This is one of my favorite things in geometry because it actually has really obvious application. So it says an artist wants to balance a triangular piece of wood at a single point so that the triangle is parallel to the ground. Notice it is balanced. He's going to balance that point right there. So somewhere on this triangle, there is a center of gravity, and we're going to find that. So where should you find the center of gravity? It has to do with the centroid. The centroid is where all the medians come together. And the solution goes through it step by step. See, center of gravity. And it tells you what to do. So find the midpoint of all 3 sides of the triangle. And you can do that by using a compass, using congruent circles, kind of finding the perpendicular bisector. But you're actually not making it perpendicular. You're just finding the midpoint, that point where it's bisected. And then you're connecting that point across to the vertex. And you're going to go through, there's all the medians. So here's the midpoint all the way across to the vertex. And that point right there is the centroid. That is the center of gravity. And if we were live and in person, I would actually make you have to find the center of gravity and have to balance a triangle on the tip of your pencil. And if you could do that, you know you've got it. Okay, we're going to try it. Now, this, again, because it's on the computer, it's a little bit more challenging, but it says use the medians of the triangle to locate its centroid. So if I took this and I actually found the midpoint of this side and the midpoint of this side and the midpoint of this side, and then connected the midpoints to the vertex across from it, all those lines, all three lines would come together to find the centroid, that center of gravity. And if you can, do it on this program. Use the construction tools, use the compass, find the midpoint, and then go across. And if it's difficult for you on the computer, then do it on paper and pencil. Use an actual compass and figure out where the centroid would be located on any triangle. Now it says move the vertices to make your own triangle. So you can manipulate this. I'm going to drop this down. You can manipulate this a little bit. Notice it's always at the midpoint, each of these segments. Start at the midpoint, and it does change depending on if it's a right triangle, acute triangle, obtuse. Mess with it, and it says, how can you verify? Well, think logically. If you were finding measurements, you might use a ruler. So how could you do that? What would you measure to determine if it's 2/3 or 1/3? And you can actually do this on this triangle or a different triangle, and you can manipulate this format. Concurrency of altitudes. So all the altitudes, that's kind of like the height where it goes at a 90-degree angle across from it. They will all come together at one point, and that point is their point of concurrency of the altitudes. It is called the orthocenter. So the altitudes create the orthocenter. The medians create the centroid. Again, all this vocab is really confusing. You don't use it a ton, so definitely write that down. So all the medians, where they come together, that creates the centroid. All the altitudes come together, that creates the orthocenter. So it says, the point of concurrency of the altitudes of a triangle. How does the type of triangle relate to the location? And you could sketch this out, maybe do some sketches, and the solution's here so you can determine how is it like a right triangle, obtuse, acute, how does that affect the location of the orthocenter? Then you're going to try it. What is the relationship between isosceles triangles? So does that make a difference? If it's right, acute, obtuse, and now that it's isosceles, how does that change? And use the tools or use your own paper and pencil and compass to determine how it changes. The answer is here. So again, if you get stuck or confused, you can type in your answer and then check it to see if it's right. Finding the orthocenter. So it's not always going to be paper, pencil, compass. It might be on a graph. So first of all, the orthocenter, it takes this vertex and goes at a 90-degree angle perpendicular to the side opposite for each vertex, 90 degrees opposite. So on a graph, this is going to be kind of confusing. So what I'm going to do is I'm going to kind of sketch this graph out on my whiteboard. And then on my whiteboard, I'm going to go through the math step by step, all the algebra. It's a lot of algebra, so be ready and get ready to write this down. All right, here's the problem. I drew it out for you. It's not the best, but you get the idea. We are going to find the altitudes of each of those, but we're going to have to use our algebra skills. So I need to use or find the slope from this line right here. Now, if I find the slope, I can figure out what the slope is of the line opposite or perpendicular because it's the opposite reciprocal. So if I found the slope here, and I'm going to write the slope formula, y2 minus y1 over x2 minus x1. And just for simplicity reasons, I'm going to call this x1, y1, x2, y2. You can do this on a graph and count, like rise and run. You can count it and figure out the slope. But I'm going to go here and actually figure it out in case you don't have an actual graph. Because I think there's one of the problems where you don't get an actual graph. You just get ordered pairs. So I'm going to take 5 minus 12 over the x2's 10 minus 3. That's a 3. Okay, so I have my slope, bringing down the slope. My slope is negative 7 over 7, which reduces down to be a negative 1. So my slope of this line right here is negative 1, but I need the perpendicular slope. That would be 1. So I've got my slope. My slope is 1 that I need to go from here, but I need to go to the opposite vertex. So I need an equation of a line that goes through this point with a slope of 1, 1. Now, because I have a graph, I can actually graph. Okay, from this point, go up 1, over 1, up 1, over 1, up 1, over 1, until I get to over here. And then I'm like, okay, nice. There would be my line. Okay, that would be the altitude right there. But it doesn't always work as easily because what you're needing is not just the equation of the line. You need where the other altitudes come together. Where do they intersect? So that's going to require some more math. So I'm going to pick another segment. I'll pick this one down here, K to L. And I'm going to find the slope of that line. So I'm going to grab a different color here. And I'm going to use right here, these 2 points. I've already got x2, y2. So I'm going to label this x1, y1. So I'm going to use the slope formula again. y2 minus y1, x2 minus x1. So I've got these labeled. So I am going to have slope equals 5 minus 0 over 10 minus 0 happens to be 0 because it intersects with that origin. So I have 5 over 10, which is just 1/2. Okay, but I don't need this slope. I need the slope perpendicular to this. So I need the perpendicular slope, which would be the opposite reciprocal. So instead of 1/2, it's a -2. So this is the slope I need. Okay, from this slope, I can move from this point opposite because the median will go from a certain point, the vertex, to the side opposite. So I'm going to go from here down 2 over 1, down 2 over 1, down 2 over 1. Keep going. And it's going to look something like this. Remember, this is just a sketch. Notice they intersect at one point, that point of concurrency, which I could do this other vertex and a cross. But I'm just going to do these two for simplicity reasons and because it's just going to get too messy. So I need to figure out where they intersect. To do that, I need more than just the slope. I actually need equations of the line. So what I'm going to do is I'm going to save these just so I remember. So I'm going to say that this slope right here in the pink line, that slope is 1. Okay, and from this green, this line, the slope is -2. Okay, so that's what I need to save. Everything else I'm going to erase. Most of you feel comfortable, at least most of my students feel more comfortable with the slope intercept, y equals mx plus b, slope intercept form of line. I think the textbook or this interactive textbook uses the point slope, which is y minus y1 equals m times x minus x1. Either way is fine. So you can use the slope intercept form of a line or point slope form. Whatever works for you. Since my students like this one better, I'm going to go with it. So I'm going to take one of the points that I know is on my lines. And I'll start with the pink. This pink m equals 1. So I know for a fact that this pink line intersects at 0, 0. Okay, which means my y is 0. My x is 0, and my slope is that 1. And I need to find what b is. Okay, so you plug in your points. You plug in your x and your y and your slope, and then you solve for b. Well, this is 0 equals 0 plus b. Not very exciting. b equals 0. So I'm left with y equals, and then I plug things back in, my slope x plus my y-intercept, which I don't need. So it's just y equals x in this case. You may or may not have the invisible one. Okay, there's the equation of that pink line. Now to find the equation of the green line, same concept. You take the slope, and again, I will use the slope intercept form just because that's what my students like best. Okay, and I'm going to use the slope, which is -2. I know that this line goes through point M, 3, 12. So I'm going to use the 3 and the 12. The 12 is the y, the 3 is the x, and I'm solving for the b. Okay, this is -6. I'm trying to make sure my 6's and b's aren't confused. I'm going to add 6 to both sides, so I have 18 equals b. And once I know what 18 is, then I plug it back into the equation of the line. Y equals mx plus that b. So I've got these two equations of the lines. But again, I still don't have the answer. The question asks you to find the point where the altitudes meet, or the orthocenter. So this is where it gets even more tricky. I am going to use system of equations to figure out where these two intersect. So it's been a long time probably since you've done this in algebra. So I'm going to take, and I'll write it a little bit differently. I'm going to take y equals x, that pink equation, and y equals negative 2x plus 18. And I put them together like this so you know, oh, systems of equations. You can solve through substitution, elimination. You can even use graphing, but sometimes the graphing isn't as accurate as you hoped. So I look at this and I'm like, hey, I could use substitution. I could take this x and just substitute it in for the y into the other equation. And that's what we're going to do. So we're going to take this equation, that x, and replace it with y. Okay, we're going to use the substitution method. So instead of y equals negative 2x plus 18, I'll have x equals negative 2x plus 18. Notice I substituted. I'm going to move the 2x to the other side. So I have 3x equals 18. Solve for x. So x equals 6, which means where these two lines intersect, this point right here, the coordinate is 6 for the x value. We just need to find the y value. So I have to take that 6 and plug it back into one of these equations. Well, it's kind of nice because x equals y. So if I have x as 6, y would be 6. And I've got my actual coordinate. So I go back up here. This point right here, the point of the orthocenter, would be 6, 6 as the ordered pair. That's a lot of algebra for one problem. And so you do have to find the slope of the line, the perpendicular slope of the line, find the equations of the lines, solve using systems of equations, and then solve for the actual coordinate. All right, find the orthocenter. Here's the exact same problem we just did on the whiteboard, except they're not giving you a graph. So you're going to use those 3 points, find the slope of 2 of the lines, the point across from it, and I would recommend actually drawing it out. It makes it a little bit easier. And I want to see if you can do this the exact same way we did on the whiteboard, but by yourself. And you can check your solutions here. All right, concept summary. This is the big ideas. So the centroid, again, write this vocab down if you haven't. Medians, find the centroid. The median is the midpoint of one side connected to the vertex of the other side. And the short side is 1/3 of the total. The long side is 2/3 of the total length of the median. Where the altitudes are like the height, that 90-degree angle, that intersection. It's the point of concurrency, the orthocenter, where all the altitudes come together. And it could be like on the triangle, if I can get it on the triangle. It could be in the triangle. It might even be outside the triangle, depending, it's hard to tell, depending on how your triangle is faced. And it's acute, obtuse, or right. So that is the orthocenter. I hope that helped.